Hey everybody, this is a video going over how to find the missing side of a right triangle. At the top here, it is mentioned that this is a review topic. Obviously, you've already covered this in geometry. I'm just going to go quick over this review question, and then we'll look at the bottom here. These questions are I would argue, the hardest type, where you're only given one side and one angle. In some practice questions, they will probably give you one side, one angle, and then tell you which side they're looking for. For ours, we're saying let's find all of the sides. And that is why it's a little more difficult. But when you're practicing it, it might only ask for one angle, so you might not have to do all of the work for each question like we're showing, but I'll go over that as well at the end. Here at the top, it says review how to use the Pythagorean theorem to find a missing leg length. So if you have two sides of your triangle and you're only missing one side, you can just do the Pythagorean theorem. That is the easiest way. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. And what we'll do from here is label a, b, and then we already have c labeled. That is our hypotenuse. It's always the one that is across from the right angle. I'm just going to plug it in here. So a squared to be 30 squared plus b squared to be the square root of 10 squared. And then equals c squared. Then we'll type this entire part into the calculator. 30 squared plus the root of 10 squared is 910. And then we'll just take the square root of both sides. Depending what it's asking for, your answer will either be exact, so square root of 910, because that cannot be simplified, or you would find the approximate answer. It will normally specify how many things it wants behind the decimal, how many places, sorry. So let's say we're asking for the 10th place. I'm going to type in the square root of 910, and I get 30.166, so it'd be 30.2 would be the rounded answer. And that is how you use the Pythagorean theorem, just to remind us there. We also had this on our last couple sets of notes. In the center here, kind of dividing the page, I have all of our trig ratios, well, the normal ones, not the reciprocals. So sine, cosine, and tangent. Just a reminder, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So what we're going to do is look and see what we're given, and we're going to fill it in on our triangle. And it's asking us to find all of the sides of our triangle. So we'll label the sides we don't have, and then we can use whichever ratio makes the most sense. It'll be one or two of them. The third one will normally not make sense because you obviously will have a missing side that you couldn't fill in. So example number 1 says, find all sides of a right triangle that has a hypotenuse of 15 and an angle of 60. So given information here, we have a hypotenuse, which is C, of 15, and we were given one of our angles is 60 degrees. It says find all sides. So needed, I need A and B. I'm trying to find A and B. So I'm going to go over here and I'm going to label. C is here. It's across from the right angle. And that answer we already have is 15. So I don't have A or B. And then I also have a angle of 60. You can put it wherever you want, since you're making your own diagram. Obviously, if you were given a diagram, it would just already be on there. But since we're making our own, we can put it wherever we want to. Obviously, you just couldn't put it here because that's already 90 degrees. Now, from here, I'm just going to label what I have, or actually, which side is which, I guess is a better way to say it. Our hypotenuse is here, obviously. It's the one across from the right angle. Because we're given the angle of 60 in this corner here, that would make this side the A side, the adjacent side. Remember, because your angle is always composed of the hypotenuse and the adjacent side, which would make B over here the opposite side because it's the side that is across or on the other side over there from your angle. Now, what I'm going to do is pick the ratio that makes the most sense for what I have. I would not pick the one where I don't have either of the sides. So if I'm looking at this one, if I want to use tangent, I want to find the tangent of 60 is the opposite side over the over the adjacent, not that. Here, I wouldn't use this one because I don't have either of these values, right? I wouldn't be able to simplify this because I don't have A or B. I would have to pick one where I have part of the fraction. So here I have opposite over hypotenuse. I don't have the opposite side, but I do have the hypotenuse, so I could use that one. Here I have cosine is adjacent over hypotenuse. I don't have the adjacent side, but I do have the hypotenuse, so I could also use that one. So you could use sine or cosine. It doesn't matter which one. I'm just going to pick sine because it's the first one there. So the sine of 60 equals the opposite side, which in our case is B, over the hypotenuse, which in our case is C, or 15. Now what I want to do is solve for B. Right now, I'm just going to use normal equation rules. I know this equation looks a little fancy, but you're just going to do a normal equation rules. So to undo what's happening to B, if I want to solve for B, I'm going to get B by itself, or you might have heard that as being called isolating B. Right now, B is being divided by 15. The inverse or opposite of divide is multiply. So if I multiply both sides by 15, that'll cancel out the 15 on the right side and get B by itself. So right now, B equals 15 times the sine of 60. And then you just type that in the calculator. I'm going to go over to my calculator. When you're doing this, you want to make sure your calculator is in degrees. See this button right here? That's radians, that's degrees. It will make a difference. If you ever get a negative answer when working with a triangle, it's probably in radians, switch to degrees. So I'm going to type in 15 times the sine of 60. And I got 12.99. The question told me to round to the nearest tenth. So my 12.9 would be rounded up to 13.0. And that would be the side B. So I now have this side here. It's 13.0. The only one I have left is A. So to find A, now I have two sides of my triangle. I don't need to do another ratio. I can just use the Pythagorean theorem. A squared plus B squared equals C squared. And then just solve for A like we've been doing the last couple days. Excuse me, sorry. So here I got 15 squared minus 13.0 squared. And I got 56. Now, A is not 56. Obviously, that wouldn't make sense. That'd be way too big. I'm going to do the square root to get A by itself, and that will be A. The square root of 56. And I said we want to round all of our answers to the nearest tenth. So 7.48 would round to 7.5. And that is the other missing side. I'm just going to label it on our triangle as well. And there we go. So here were the two answers we were looking for. Oftentimes, though, your question will only ask for one of them. If it only asks for one of them, obviously you would just find that one missing side here, and then you wouldn't have to do this extra step down here. Okay, let's do it again. Number 2 says, find all sides of a right triangle that has a leg length of 30 and an angle of 58. Round all sides to the 10th place if necessary. So leg length of 30. They specifically did not say hypotenuse, so we don't have C. Leg length would be A or B. It doesn't matter which one. You can call it whichever one you want. They're interchangeable, so I'm going to say it's A. And then we have an angle of 58. Meaning we need, it says find all sides. We need B and C. So I'm going to go ahead and label over here. I already have C labeled. A is 30, and B we don't have. And then angle of 58. You can put the 58 here, or you can put the 58 here. It doesn't matter which one. Okay, perfect. Now I have the adjacent side to my angle, right? I don't have the hypotenuse. I know that's across from the right angle. I have the adjacent side because this is next to my angle right here. Remember, your angle is always composed of the hypotenuse and the adjacent side, which would make B the opposite side. I don't have that side either. So if I'm looking over here, the one I would not use is sine because I don't have either of the things I need for sine. So I'm going to pick one I do have the stuff for. I can either do cosine or tangent. I haven't used either one yet. I'm going to go with cosine just because we haven't done that one yet. So the cosine of 58 degrees equals the adjacent over the hypotenuse. So here's my fraction. I'm going to do the same thing I did last time. I'm going to multiply because I'm dividing by C, both sides by C. That would cancel it out on this side. That's just to get rid of my fraction because you can't really get rid of it any other easy way. And then now This unfortunately is not my answer yet. It is an extra step. C is over here. It still has this stuff next to it, but it's being multiplied now. So now I can divide by the cosine of 58. And that would isolate my C to get it all by itself. And then I'm just going to type in everything I have on the right side into the calculator, just like before. So my fraction, I have 30 divided by the cosine of 58. And that gets me 56.6. And there we go. I'm going to label that here. C is 56.6. And I'm missing one side now. I don't have B yet. To get B, I will just plug all this in to my Pythagorean theorem. So I have A squared plus B squared equals C squared. Then I just solve for B. Remember, I'm subtracting because it was adding. That's the opposite. Well, it was positive. That's the opposite. Now I'm going to type this in. Excuse me. So 56.6 squared minus 30 squared. And that gets me 2,303.56. I know that feels large, but this is a big triangle. So now I get the square root. Remember, I don't need to have a simplified answer. I just need to have a rounded one to the nearest tenths place. I'm going to type this in. And that gets me 47.995, which would round to 48.0. I'm going to label that over here. 48.0. And there we go. So these are the two answers we were looking for, this one and that one. And then just a reminder, if it only asks you for one of them on a practice, you wouldn't have to do the second part. You would just do whatever ratio got you the one you're looking for, and then you wouldn't have to worry about the Pythagorean part. Perfect. Okay, I want you to see if you can get anywhere on your own. So try this one. Pause and then come back when you're ready. When you unpause, I will have the entire answer on the screen. Okay, here is the question. You should have gotten a B, or if you called it A, the leg length was 3.3, and then our missing hypotenuse was 9.5. Here's how I did it. If you did something different, if you labeled differently, they made you do a different ratio, and you got the same answers, you are still correct. Do not erase. Only erase if you're wrong. As you should have 3.3 as a side length, square root of 80 as a side length, and then the hypotenuse should be 9.5. If you have them swip-swapped around, that's totally fine, as long as your hypotenuse is 9.5. The other two don't really matter which one's where. And then if you did a different ratio, as long as you got the side was 3.3 and the hypotenuse was 9.5, that's all that matters. Okay, and then I'm going to show you, just real quick, this is not on the notes. You don't have to write this on your notes if you don't want to. If you want to put it in the margin, you can. This is what the questions normally look like. So like I said, our notes were a little bit harder than the questions you're going to see just because I wanted you to be able to handle it all. Here's how you'll normally be given a question. It will just ask you to find the missing side. So there's only one side they're asking you to find. They just want you to find X here. They give you an angle and another side. So what you would do is not just pick a random ratio. You'd pick the ratio that gets you this without having to use the Pythagorean theorem as a second step like we did to find all the missing sides. So here I have an angle. I'm given the opposite side. This is the opposite of my angle because this would be the adjacent side. And then I'm looking for the hypotenuse. So I would pick the ratio that involves the opposite and the hypotenuse, and that would be sine, because sine is the so part of SOHCAHTOA. So the sine of 40 equals the opposite, which is 10, over the hypotenuse, which is x. And then we would just solve for x like we did in our notes. So you'd multiply both sides by x. That would cancel here. We would get x times the sine of 40 equals 10. And then you just divide by sine of 40 to get the x by itself. And then you just type that part in the calculator. So I would do 10 divided by the sine of 40. And I got 15.557, so 15.6. And then you wouldn't have to do anything else past that, right? Because it doesn't ask you for all of the sides. It just asks you to find x. So this is how your practice is normally going to look. This is also how the questions on your test are going to look. Okay, perfect. I hope this helped. Have a wonderful day. Bye.